Welcome to the math world, okay? And all this thing is the statement about how we can use the rectangles to approximate the area under the curve, okay? So you can try to read by yourself, okay? So let me give you like 10 seconds, okay? I'm still here. Read it from the top to bottom, okay? Too complicated? Don't worry about it. Try to read first, okay? That's it, okay? So, well, I believe you are not happy with this kind of thing, okay? But don't worry about it. Let me try to explain this one with a figure, okay? So let me move to the next slide. There we go, okay? So now let's try to explain what that means, okay? So here we go. First of all, we need curve, right? Here we go. I have curve. Let's say this is function f of x, okay? And we would like to talk about the area, just make the straight line, okay? Area under the curve from A to B. This is my target, okay? So now, again, there's no way to calculate or measure the area under this curve, okay? It is impossible, okay? But we know how we can approximate this value, okay? So like we're gonna use the rectangle, okay? We can use trapezoidal, but like, we're gonna try to start from rectangle because rectangle also can give you the exact area under the curve, okay? So what we're gonna do is like, think about it, okay? Let me come back to your elementary school, okay? So what is area of rectangle? It is base times height. Base times height. That's it, okay? So what you need for this study, you need to understand about base and height, okay? And also, we're gonna try to figure out the base and height for each rectangle, okay? Because we're gonna try to construct the rectangle under the curve, okay? So first of all, you need like base for each rectangle, right? So let's say we're gonna cut like this way, okay? So how many? And many, okay? So let's say this point is x0, then this one is x1, x2, x3, just numbering, okay? And dot, 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 and the very last one is xn. Then this previous one is xn minus 1. Are you okay so far? Okay? So now, like, this, like we're gonna say this A to B is interval, and x0 to x1, and x1 to x2, and x2 to x3. So for each small size of interval will be we're gonna say like they are subinterval, okay? These subintervals will be the base of each rectangle, okay? Now we need height of rectangle, okay? So for that purpose, we're gonna choose any point, okay? Look at this first subinterval, okay? From A to x1 or x0 to x1, okay? You can choose any point in this subinterval, okay? So for example, I chose this point. Can you see in this first interval? Let's say that is x1 star. Okay, we're going to say that is the sample point, okay? Then the function value of this point. This guy. The function value of this guy will be the height of first the rectangle. So I'm going to construct the rectangle here like that. Does it make sense? Now I made a first rectangle, okay? So again, this is the base, and the height is the function value of the sample point, okay? And for the second rectangle, I'm going to do the same thing, okay? Choose any point here, okay? Which one? Here, anyone, okay? So let's say this is x2 star. Then the function value of this point, I'm talking about this point, okay? So this will be the height of the second rectangle. F of x2 star, okay? Then I can construct second rectangle like that. Like that, okay? So we're gonna keep doing this one until the very end. So like, let's talk about like very last subinterval, okay? So from x of n minus 1 to xn, and choose any point, maybe here. Then let's say it is xn star. Then the function value of this point. This is the height of the very last rectangle, okay? So your last rectangle will be construct like this way. I should change my pen. Are you with me so far? So like, I'm talking about the rectangles, okay? So like, as I told you, I know, and you know the area of rectangle, which is base times height. So now let's try to write the base. What is base? Like we're gonna say the base of first one is delta x1, okay? Delta x1 is what? x1 minus x0, right? Okay. Then what about second one? The base of second subinterval. We're going to say that is delta x2, that is equal to x2 minus x1. And so on and so on. Okay, we're going to keep doing this, okay? And what about the very last one? The base of the very last rectangle is delta xn. That can be found xn minus xn minus 1. So we just figured that out, all the bases for each rectangle, which is noted by delta x1, x2, x3, and delta xn minus 1, right? And also, we already found, like, the height for each rectangle. The first one is what? F of x1 star. The second one is f of x2 star. And dot, dot, dot. And the last one is f of xn star. These are the height of rectangle, okay? Now we're ready, okay? Keep that in mind. I'm keep talking about base times height. That's it, right? So what about the area of each rectangle? Here we go. The first one is base delta x1 times height f of x1 star. That is the area of this rectangle, right? Then what about second one? The base is delta x2 and the height is f of x2 star. The third one, delta x3 times f of x3 star, and dot, dot, dot. And the very last one is delta xn and f of xn star, okay? It should be better to change the color too. Oh, better. Are you with me so far? I'm keep talking about the area of the rectangles, right? So now, do you agree with me? If I add up all the area of rectangles, it could be the approximation area under the curve, right? So I'm gonna add everything. Dot, 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 and until the end, right? That's it. So we can say that is approximation of area under the curve, right? So, well, at the beginning of this class, I was talking about the sigma notation, okay? Look at that. Can you find the index? Yes, 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 you can do it. Here we go. I'm talking about this value. 1, 1, 2, 2 for the second term, and third term, 3 and 3, 4, 4, 5, 5, and the very last one is n and n. These are index I. Okay? So since we figured that out, which is index, we can write this one in a sigma notation. Sigma, your index I is changing from 1 to n, and then delta xi, because this one is replaced by the index I, and then f of xi star, right? Well, like this is not the not the way to write in math, okay? Let me switch this to, okay? So we can write this one as sigma I is from 1 to n. Let me write function first, okay? Height first times base, okay? That's it, okay? So you know the name of this one? This is the Riemann sum, okay? Okay, but unfortunately, this is still the approximation area under the curve, right? Then how can you make it real area? Well, let me give you like just silly idea about this, okay? So now, like my base is like that, so like the difference is too big, right? But if I have more rectangles, then which means like like your rectangle will be narrower and narrower and narrower, okay? Just narrow rectangles, okay? Then you have more rectangles, okay? Then do you agree with me? It will be better approximation? Yes, it is true, okay? Then later we're going to talk about upper sum and lower sum, okay? Then upper sum is always like, bigger than the real area, and lower sum is always the less than the real area, okay? But when you have infinitely many rectangles, then interesting is like your upper sum and lower sum will converge to the same point, okay? Later we will talk about this one later, okay? It is the squeeze theorem, okay? Or like, you learned about this already, okay? By the squeeze theorem, we can say your upper sum and lower sum is equal to each other, which means they converge to the real area under the curve, okay? This is the way to find exact area, okay? This Riemann sum is still approximation, but the real area, exact area is equal to limit n goes to infinity, which means you can have infinitely many rectangles, okay? And f of, sigma I is equal to 1 to n, f of xi star times delta xi, right? So later we're going to use this notation, but like this is exactly the definite integral, okay? It is equal to integral a to b f of x dx. Later we will use this notation. What is the definition of this notation? There we go. It is limit of Riemann sum.